purpose of this talk is to give a high level of overview of the industrial Internet of Things, why it's topical and how it's applied. We will give some examples of how IMR is demystifying IIoT for members and some of the use cases we've applied IIoT technology to. So let's provide some background in terms of IoT first, or the Internet of Things. IoT is simply about connecting a physical thing to the cloud. This has arisen simply because of the affordability of key technologies such as sensors, bandwidth and processing. As you can see in the slide here, there's been significant reductions in costs over the last 10 years, enabling these technologies to be applied in more cost-effective manner to different use cases and problem situations. This evolution has also impacted industry and industrial applications such as manufacturing, supply chains and energy management, where this connectivity approach enables significant improvements in data collection, exchange and analysis to deliver better business value. This convergence of sensors, communication and cloud can be applied in customizable and cost-effective solutions, supporting a range of new applications such as artificial intelligence and machine learning, real-time analytics, cobotics and blockchain, as well as some of the more widely known and applied applications such as condition-based monitoring and asset management. So some additional context. So IIoT is often mentioned along with Industry 4.0 or I 4.0. Industry 4.0 refers to the concept of factories in which machines are augmented with wireless connectivity and sensors connected to a system that can then visualize the entire production line, control this and make decisions. So effectively, Industry 4.0 is about networking different units within production systems to acquire better data analysis and to deliver better business value. In essence, Industry 4.0 describes the trend towards automation and data exchange in manufacturing technologies and processes, which can include capabilities such as cyber-physical systems, cognitive computing and artificial intelligence. This will mean different things to different industries, but the technology blocks are there to support that evolution. And essentially it's about getting the right information and right data to the right people within that manufacturing system that allows them to make decisions more effectively. So one of the key opportunities of IIoT is its ability to augment existing infrastructure within factories. We target specific data gaps and then tailor sensor-based solutions to capture the new data requirements. In that way, from a business perspective, solutions can be targeted and cost-effective. However, this does lead to specific areas which need to be addressed from a technical perspective, such as ensuring data integration with existing IT infrastructure, ensuring data security and providing initial insights into new data streams, either from the individual sensors or integrated into other factory database systems. So in terms of the overall value chain, the impact of IIoT can be far-reaching in terms of this and where the factory sits within that. After all, factories don't sit in isolation. They're generally part of a highly integrated and complex supply chain that can span the globe. Within this then, primary objectives of IIoT are to ID the type of data required, capturing that data, as we said, through appropriate sensorization, understanding this data behavior and then translating that behavior into business insights, into upstream or downstream within the supply chain. These insights can be pushed into the appropriate area. For example, you may have a critical tool or subcomponent within a factory system which constrains your overall production line. There may be information gaps within this critical system which requires further sensorization. Once you've done that, this additional data can help predict system availability and push that information downstream in terms of requirements for additional parts, or pushing that information upstream into production output performance for business partners. So from an Irish manufacturing research perspective, what we've created is an IIoT toolkit. This is to help our members on their initial steps into a digital journey in terms of proving out in a cost-effective manner the concepts of IIoT from a member-defined use case. The key features of this toolkit leverage sensor integration, using appropriate connector capabilities, wired or wireless connectivity, data streaming options and visualization. This can then augment existing member infrastructure and or support the development of new applications. So in a way, it's an opportunity for members to get to know and understand IIoT in a very simple and cost-effective manner, which allows them then to understand their own needs in more detail. So some of the use cases where we've applied this technology, and again, the use cases for IIoT are hugely varied, but we have used this technology to support customers in more efficient and granular tracking of their production metrics. We've delivered a 15% improvement in production performance for a customer using this technology. In terms of factory system performance, we've delivered a 10% improvement in output through schedule optimization through the appropriate sensing of these production systems. We've supported customers in the real-time monitoring of tools or asset performance, enabling our customers to move to a run-to-fail model on critical tool sets and away from time-based preventative maintenance, delivering a 20% cost improvement. We've supported a number of our customers in understanding their facilities behaviour and energy management in more detail, and in some cases have delivered a 30% reduction over time in energy consumption through chilled water optimization. And we've supported customers using this technology to augment life safety systems, enabling the proactive retrofitting of some of their equipment systems. So as you can see, there can be a lot of overlap between Industry 4.0 and IIoT, with IIoT being a key enabler through the generation and integration of key data sets. We've touched lightly on the benefits which can be accrued in terms of cost and operational efficiencies. The challenges are typically business specific, and what we've noted is some additional key observations. So we find that companies that have already had a lot of focus on lean methodologies tend to benefit greatly from this approach due to their already highly structured way of doing business, where IIoT can enhance their pre-existing standardization levels. We've also noted that IIoT can provide insights into what skill sets are needed in the future and what a workforce role could potentially look like with IIoT. We've noted how infrastructure need to change to accommodate new data sets and how disparate sources need to be integrated to provide business value. But again, these are all opportunities that we've noted that companies are embracing over time. Thank you for your time.